And this will bring us to the topic of consensus. This term appears frequently and can be used to refer to a range of different things, leading to some confusion. But at a fundamental level, all consensus really is the process of getting a group of nodes or computers or processes on a network to agree and keep in sync. That's really it. So this is not something that's inherently unique to blockchain. It's actually a common problem in most distributed computer systems. And when you hear mentions to specific algorithms like a proof of work or proof of stake or whatever it might be, those are specific ways or implementations of achieving this consensus process. But just bear in mind that these are specific examples of types of algorithms for consensus, not the definition of consensus itself. So when it comes to the concept of consensus within a blockchain, we're referring to the process by which the nodes in the network come to agreement on the sequence of these blocks in the chain, which is ultimately what's going to address the potential problem or threat of double spend. A ledger, by definition, being a history of transactions. In order to have correct balances, the entire network must agree on who paid whom and when. So it's useful for a moment to consider being a node on one of these networks. So just remember there is no central source of truth or information that all these nodes are getting their data from. They can only get information and data from other nodes that they're able to communicate with on the network. So for any given node at any given time getting differing messages from adjacent nodes, this is a manifestation of the problem that consensus needs to address. And there are different reasons why any given node might be providing incorrect information to the rest of the network. It may be in a crash state and providing no information at all, or may have returned from a crash state and have outdated information, or messages over the network may have been dropped, causing it to be out of sync. And this is what you'll commonly hear referred to as crash fault tolerance when referring to consensus algorithms. It's also, of course, possible that different nodes on the network may intentionally be providing incorrect data. If we take open, permissionless networks, for example, we don't necessarily know who is controlling these given nodes on the network, and they may be, in fact, manipulating the data that is sent from that node. And this is what you'll commonly hear a consensus algorithm be referred to as Byzantine fault tolerant, in reference to the ability to handle this particular type of failure. So we'll return to specific types of consensus algorithms at a later point, but to summarize the concept again here, consensus is the process by which we get all nodes on a network to reach some decision about the state of the network, and where all properly functioning nodes reach the same decision or the same output for the state of the network.